Hello and welcome to another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 7, Lesson 10 on factoring challenging trinomials. This is our last lesson of the unit, all right? And our unit has been all about polynomials and how to multiply them, add them, subtract them, how to factor them, etc. Today we're going to be looking at factoring more challenging trinomials. So let's talk a little bit about this. All right, trinomials with a leading coefficient other than 1. So far, all we've done is factored trinomials where the leading coefficient, the number that multiplies the x squared typically, is the number 1. So it's not typically even written, all right? Factoring trinomials with a leading coefficient other than 1 can be very challenging for students. It often tries their patience like nothing since, let's say, long division with decimals. That's a good comparison. Although I still think it's easier. The first thing that we need to do before we do this kind of factoring is we need to, yet one more time, review how to multiply two binomials together. All right? So let's take a look at exercise number 1. Find each of the following products in standard polynomial form. Use any appropriate method. All right. So let me just remind you that we've actually got 4 different methods for multiplying two binomials together. We've got the standard multiplication algorithm, we've got double distribution, we've got area models, and we've got the one that's most commonly used, which is the FOIL algorithm, right? So whichever one you prefer, I'd like you to pause the video now and multiply each one of these out so that you get a trinomial at the end. All right, now I'm going to use FOIL in each case, and you'll see why that is as we go through this lesson. But let's do it, all right? So in letter A, right, I'm going to do 2x times x, which is 2x squared. That's my first. I'm going to do 2x times 7, and that's 2 times 7, which is 14, and just the x comes along for the ride, right? I'm going to do my I, which is 3 times x, or 3x. And then I'm going to do my L, 3 times 7, sorry, which is 21. All right, as always, the only two things that combine are the 14x and the 3x, and in this case, that's 17x, and then plus 21. All right, we're just going to go through each one of these in turn. All right, for this one, my first term is 4x times 2x, which is 8x squared. My outer term, 4x times 5, is 20x. My inner term, negative 3 times positive 2 is negative 6x. And last, negative 3 times positive 5 is negative 15. We combine those two center terms, the O and the I, and we get 8x squared plus 14x minus 15. All right, finally, we have 3x times 5x, which is 15x squared. 3x times negative 1, which is negative 3x. Negative 4 times positive 5x is negative 20x. And negative 4 times negative 1 is positive 4. That gives me 15x squared minus 23x plus 4. All right. Now, before we move on, I want to point out something very important about multiplying two binomials that we've pointed out before, but I really need you to understand it. All right? Take a look at this final answer compared to, and I'm gonna erase this, compared to the original product. Where does the 2x squared come from? Well, that comes from the 2x times the x, right? 2x times x gave me the 2x squared. Where did the 21 come from? That came from the 3 times the 7. So literally, this is the F in FOIL, and this is the L in FOIL, right? And the same thing is true in each one of these, right? 4x times 2x is 8x squared. Negative 3 times positive 5 is negative 15, right? 3x times 5x is 15x squared. Negative 4 times negative 1 is positive 4, right? It's the O and the I, right? The O and the I that combine to give us the linear term in the middle. But the first term in our product, in our trinomial, and the last term of our product in the trinomial simply come from multiplying firsts and lasts. And that is very important before we get into this more challenging factoring. Now, it's important to be able to determine the linear term of a trinomial without completely multiplying the two binomials, okay? Right? And again, just as we talked about, if I have 4x plus 7 times 3x plus 2, right, my f comes from doing the 4x times 3x, my L comes from doing the 7 times the 2, right? The O, right, which is 8x, and the I, which is 21x, those two combine to give me 29x, right? They are what give me that linear term. So that's what I'm keying in on right now. Just the O and the I combining to give me that linear term. So let's take a look in exercise number 2. For each product shown below, determine the linear term of the result by finding the O and the I terms in the FOIL method and then combining them. Show your calculations. Okay, so I want to be very clear about this. I'm not asking you to multiply these all out. All I want to know is if I multiply them all out, what would be the linear term? What would be the thing after the x squared but before the constant? All right, and that's simply that O and the I. Let's do letter A together, right? So in letter A, right, the outer term would be 5x times 3, which would be 15x. The inner term would be 2 times 2x, which would be 4x. And when I add those two together, I'd have 19x, okay? Now again, please don't mistake me here. I am not saying that when you multiply these two binomials out, you get 19x. I'm saying 19x would be what the O and the I in FOIL would be combined to be. Pause the video now and see if you can figure out the linear terms in those two cases without multiplying the whole thing out. All right, well, here we go. I'm going to do it without writing all of these things out. I've got 3x times negative 4, which is negative 12x, plus 10 times x, which is 10x. So my linear term in this case would be negative 2x. And in letter C, my outer 2 would be 6x times negative 3, which would be negative 18x. Negative 5 times 2 is negative 10x. A negative 18 and a negative 10 would combine to be a negative 28x. All right. All I'm trying to do is predict that middle term because it's the most complicated of them all, right? The first and the last terms are easy, right? But it's that middle term in the product that comes from combining the O and the I from FOIL. All right. Now let's start to think about more challenging factoring. Factoring challenging trinomials. We can now factor trinomials whose leading coefficients aren't equal to 1. We will attempt to find the two binomials that give us the trinomial using a process that I call intelligent guess and check, okay? And I'll explain why I put the word intelligent in there in a moment, okay? But let's take a look at exercise number 3. Consider the trinomial 6x squared plus 19x plus 15. Two guesses at the correct factorization are shown below. Letter A, why are both guesses reasonable given the original trinomial? All right, well, let's talk about this together, right? Because ultimately, the way that we're going to factor trinomials when the leading coefficient isn't a 1. Now, if that leading coefficient is a 1, in other words, it's just x squared plus something, right? Then we play that game where we're looking for two numbers with that product and that sum. I'm sorry, with that product and that sum. I apologize. That product and that sum. When the leading coefficient isn't 1, we can't do that. Okay, we literally have to guess, oh, maybe it's this times this. And then we multiply it out and we go, well, yeah, I was wrong. Okay, let me guess again. This times this. And we multiply it out and we see whether it's right or not. So both of these are reasonable guesses. Now, why is that? The reason why is, right, if I did 6x times x, I'd get 6x squared. And if I did 3 times 5, I'd get plus 15. Right? Likewise, if I did 3x times 2x, I'd get 6x squared. And if I did 5 times 3, I'd get plus 15. Right? So, in other words, they're both reasonable because both match the 6x squared and the positive 15 terms. All right? In other words, it would not be reasonable, right? It wouldn't be reasonable for me to guess, let's say I had 5x plus 15 times x plus 1. That would be an unreasonable guess, right? And it would be unreasonable because 5x times x isn't 6x squared, it's 5x squared. So even though 15 times 1 is positive 15, that guess wouldn't make any sense at all because the f part of FOIL doesn't match up. Now, let's take a look. Let me get rid of all of that. Let's take a look at letter B. Determine the linear term of each guess and check, then state which is the correct factorization. All right. So in other words, these are reasonable guesses, okay? But I don't want to multiply them all out. I already know the 6x squared and the 15 work, right? I don't need to check those. I just need to check to see which one of them, which one will have a linear term equal to 19x. Let me get rid of all of that so we can see it. I need to figure out which one of these has a linear term equal to 19x. So pause the video now and do exactly what we did in exercise 2. Just figure out the linear term of these two, and then whichever one gives you 19x, that's your winner. All right, well, I'm going to do that right up here since I've got a little bit of space, right? So for the linear term here, you kind of move that out of the way. I'd have, whoops, immediately wrong. I'd have 6x times 5, which would be 30x, plus 3x gives me 33x, right? That would be the O and the I combined. Here I'd have 3x times 3, which would be 9x, 5 times 2x, which would be 10x. Add those together, and I have 19x. Right? We already know because the guesses were reasonable that the 6x squared and the positive 15 are going to work for both of them, right? But this one, if I did the multiplication all the way out, would give me 33x in the middle. This one would give me 19x in the middle, and that's my winner, right? So this, correctly factored, is 3x plus 5 times 2x plus 3. And that's it, right? And we're going to get practice on this and guessing and checking and all of that in a moment. But let's just make sure that you kind of understand this. It is very important to be able to quickly tell if a reasonable guess is the correct one for the factorization of these trinomials, all right? So let's take a look at exercise number 4. Is 2x minus 5 times x plus 4 the correct factorization of 2x squared minus 3x minus 20? Justify your yes/no response. All right, so the first thing I would ask myself is, do the first and the last terms match up? Well, 2x times x is 2x squared. Great. Negative 5 times positive 4 is negative 20. Great. So at least it's a reasonable, intelligent guess. The question is it correct? Pause the video now and see if you can figure that out. Well, again, without multiplying it all the way out, I really don't need to do that because I know, right, that the first and last work. All right, I can take a look at, first, let me go with my outer. 2x times 4 is 8x. Negative 5 times x is negative 5x. That's equal to positive 3x. Here I should have a negative 3x, so the answer is no. Right? It's that simple, it's no. I don't need to see if when I multiply it all the way out, it's equal to this. I need to just check, you know, is this times this equal to 2x squared? Yes. Is this times this equal to negative 20? Yes. Now work through the linear. Oh, no, that doesn't match, so it's wrong. Okay? Let's see if you can handle this in a multiple choice setting before we go on to some free response, which is definitely the hardest. Exercise number 5. Which of the following is the correct factorization of 4x squared plus 5x minus 6? Justify your selection. Okay, awesome. So here's the first thing I want you to do. I want you to look at all 4 choices and I want you to eliminate any of them that are unreasonable. based on the F and the L of FOIL, okay? Pause the video now and see if any of them are just completely wackadoodle. They can't possibly be correct based on F and L of FOIL. I'm gonna have to get wackadoodle more into my vernacular. Okay, maybe I'll have to get vernacular more in. All right, so one of them that is just completely wackadoodle is choice 2. Choice 2 shouldn't even be considered because 2x times x is 2x squared, and I need 4x squared. So that one's wrong. I'm not going to even think about it, right? The F doesn't even match up. Now the rest of them are at least reasonable, right? 2x times 2x is 4x squared, 3 times negative 2 is negative 6, 4x times x is 4x squared, negative 3 times 2 is negative 6, and 4x times x is 4x squared, and 6 times negative 1 is negative 6. Okay, good. Now that we've eliminated number 2, I'd like you to pause the video. All 3 of these are reasonable guesses. What I want you to now do is not multiply them all out. I want you to just come up with the linear term of each one of them when multiplied out. One of them is going to be equal to 5x, and that's going to be your right choice. Pause the video now. All right, I always love thinking about this as the double rainbow. We've got this and this, right? So my linear term here is going to be negative 4x plus 6x, which is equal to 2x. I'm looking for a 5x. That one's wrong. All right, this one I'm going to have 4x times 2, which is going to be 8x. Negative 3 times x is minus 3x. 8x minus 3x is 5x. And that is my winner. I won't even take a look at 4. I won't even waste your time on it, right? And that's basically the essence of it all, right? The key is you really have to feel comfortable with multiplying binomials out, especially with what exactly gives you that linear term. Okay, so now let's do it, right? Just keep guessing. Now, students tend to really dislike these types of problems, and I get it. Because basically, I'm asking you to take a shot, to take a guess, okay, and then to check it. And if you're wrong, to go at it again. Which is why I really liken it to long division, right? Where you're like, oh man, I have to divide 12,375 by the number 72. Okay, I got to think about how many times 72 goes into blank, and then you guess, and then you work it out. No, I didn't guess right. Okay, I got to scratch that out and try again. That's the way it's done, all right? So let's take a look at exercise number 6. Factor each of the following trinomials. Show your checks, and don't worry if your first guess isn't correct. You will get better at these. Note for yourself which ones seem easier and which were harder. All right, well, let's do a few of these obviously together and kind of get a sense for it. Let me bring this up to the top of the board. Letter A. 3x squared plus 11x minus 4. Now, one of the hardest things as a teacher in terms of this is that I know what the answer is, okay? Because I've factored literally probably tens of thousands of these in my lifetime, right? So it's tough for me not to just write down the correct answer and be like, look, see, I got it right on the first time, all right? So what I'm going to do is I want to write down something that is reasonable but incorrect and show you that it's incorrect. So remember, a reasonable guess on this will be ones where the first two things must have a product of 3x squared. Well, that's going to be actually pretty easy because it's got to be 3x and x. There's absolutely nothing else that will give me a product of 3x squared besides 3x and x in terms of whole numbers. Now the negative 4, that's harder, right? Because the negative 4 could be negative 4, positive 1, positive 4, negative 1, negative 2, positive 2, and on top of all of that, you got to decide which one goes with the 3x and which one goes with the x. So you see how much harder this is than when the leading coefficient is 1. You know, when the leading coefficient of 1, it's just like, well, I just two numbers that have that product and that sum. You know, I mean, that's easy enough to think about. All right, so let me put in a reasonable guess, but one that I know is incorrect, okay? So I'm going to put plus 2 here and minus 2 here. And again, I claim that this is a very reasonable guess because 3x times x is 3x squared, and negative 2 times positive 2 is negative 4. All right, now the question is it correct? All I have to do, I don't have to multiply it all out. I just have to figure out whether the O and the I in FOIL combine to give me 11x. Well, okay, so I do these two and I get 6x. I do these two and I get negative 2x. Put them together and I get 4x. Well, 4x and 11x aren't the same. So this trinomial does not factor as 3x minus 2 times x plus 2. It just doesn't, right? Which stinks. I guessed it wrong, right? Now, the more you do these, the better you'll get at them, all right? So now, let me throw in another guess. Now, of course, it could have been 3x, it could have been 3x plus 2. That should have been locked down. 3x plus 2 and x minus 2. But I'm going to try this. I'm going to try minus 1 and a positive 4. All right, again, reasonable. 3x times x is 3x squared. Negative 1 times 4 is negative 4. That's all good. Now let's try that O and I, right? I have 3x times 4, which is 12x. I have negative 1 times x, which is negative 1x. 12x minus 1x is 11x. That's my winner. And so that is my correct factorization. Whoop. Mr. Weiler, isn't there a more straightforward way of doing this other than just guessing and checking? Well, there are a variety of methods, but they are lengthy and they are a recipe for disaster. Plus, they don't reinforce something that is very important, right? Which is the fact that this trinomial came from the product of two binomials. And all I have to do is play around with binomial products until I find the right one. Let's do another one together. Let's take a look at letter B. 2x squared plus 5x minus 33. Awesome. Again, right, when I think about this, you know, I've got to have two things sitting here and here that give me a 2x squared. And the only choice I have is a 2x times x. When the leading coefficient isn't 1, but it is a prime number, right? So the number 2 and the number 3 are prime numbers, then these are pretty easy because you only have one choice and that's it. Now the 33, there are a couple choices for that. One of them is 3 times 11 and one of them is 1 times 33. Now if you ever have something like 1 times 33, unless that center number is really, really big, I would shy away from them. It's very doubtful it's going to be 1 and 33. Maybe, but you know, not likely. So I'm thinking 3 and 11. Okay, so maybe I'll try this. Now one's got to be positive, one's got to be negative. I'm going to again go with an incorrect choice here, just to show. I'm going to guess 2x plus 3 and x minus 11. Again, very reasonable. 2x times x is 2x squared. 3 times negative 11 is negative 33, all reasonable, right? But when I do my outer, negative 22x, and my inner, positive 3x, I get negative 19x. And I'm looking for positive 5x, so that's just wrong, right? I mean, it's not even close. So switching it to negative 3 and positive 11 is not going to do much. In fact, it would only just change the sign on the answer I just had. So I'm going to switch it and put that 11 over with the 2x. All right, so let me put the 11 now here. And let me put the 3 here. And let me do minus and plus. Again, one of them's got to be positive, one of them's got to be negative. Okay, again, it's a reasonable guess. I don't have to check the F and the L. There's no need to do that as long as it's reasonable. But I do have to check the O and the I of FOIL. So when I multiply these two together, I get negative 6x. When I multiply these two together, I get positive 11x. Added together, those are positive 5x. That's what I needed. And so this is my correct factorization. All right, not too bad. I made one wrong guess, did a little thinking, corrected it, and got the right one. Let's take a look at one more together, and then we'll have you do the last three on your own. I want to take a look at one that's uber challenging, letter C. 8x squared minus 18x plus 9. Now, let's talk about why this is challenging, right? This is a particularly challenging one because the leading coefficient 8 is not a prime number, right? 8x squared could be 8x times x. It could be 4x times 2x. One of those two is going to be the case, and I don't really know which one it is. Now, I know that the last two has to be a product of positive 9. That's also tricky, right? Now, I know both numbers really have to be negative because that center coefficient is negative. If both of them were positive, there's no way I'd get a negative 18. But will it be negative 3 times negative 3? Or will it be negative 9 times negative 1? So again, let's go with some random guess. Let's go with 8x and x, and I'm going to go with negative 3 and negative 3. All right, again, reasonable, right? 8x times 8 is 8x squared. Negative 3 times negative 3 is positive 9. Those all match up, right? Let's do some O and some I, right? 8x times negative 3 is negative 24x. Negative 3 times x is negative 3x. Combine those together, and I get negative 27x. Nope. Darn it, I needed negative 18. Ugh. Okay, so thankfully for me, I hope I can just do that. I can. Okay, now in that case, I guessed an 8x and an x. Let me go with a 4x and a 2x, and maybe stick with the negative 3 and the negative 3. All right, let's see what we have here. All right, here I'll have 4x times negative 3, which is negative 12x. Here I'll have negative 3 times positive 2, which is a negative 6x. Negative 12 and negative 6 combined to be negative 18, and I got it, right? Now again, I could have been like 4x minus 1, 4x minus 1, 2x minus 9, and if I had checked that, it would be wrong in that case, all right? And then I'd have to guess again. Okay, so we guess, we check, we guess, we check, we guess, we check, keep at it. You'll start to develop more number sense and you'll eventually get these very quickly. All right, I'd like you to pause the video now and try to come up with how each one of these final three factor. Take a little bit of time. All right, well, let's take a look at 10x squared plus 9x plus 2. I like the fact that everything's positive there. Right, there's going to be no negatives going on in this whatsoever. The 10 is a bit of a challenge because it can be factored as either 10x times x or 5x times 2x. I am always biased to starting off with the 5x times the 2x rather than the 10x times the 1x. But again, you never know, right? So I'm going to say 5x and x. Now, for some students will start to develop something really nice, which they'll be like, well, if I put a 2 here, and a 1 there, right, I'd get 2 times 5, which would be 10, 1 times x, which would be 1. 10 and 1 is 11. Okay, it can't be 2 and 1. Maybe it could be 2 and 1, right? If I put it that way, right, if I put 2 and 1, well, then I'm going to have, whoops, why do I have 5x and 1x? That's not right. That's not even a reasonable guess. Like, this isn't working out at all. It's got to be 5x and 2x there. So now, if I do this, I'd have 1 times 5, which is 5, 2 times 2, which is 4, 5 plus 4 is 9. There's my winner, right? 4x, 5x, those add together to be 9x, and I've got the right answer. Right? Challenging because of the 10x squared could be either 10x and x or 5x and 2x. Let's take a look at one that's not so bad, on the other hand. One where that leading coefficient is prime, 7x squared. All right, 7x squared minus 26x minus 8. Now, we've got no choice, right? It's got to be a 7x and an x. The 8 is where we get some choice, right? 8 could be 1 times 8, it could be 2 times 4. One's got to be positive, one's got to be negative. We could play this game again where, I'm like, oh, well, which one is it? But I'm going to try a 4 there and a 2 there. And I'll just like leave it there, and then I'll put some negatives and positives there in a second. I know one's got to be negative and one's got to be positive to give me a product of -8. Now, if I did 4 times 7, right? 4 times 7 is 28. And then 2 times x is 2, right? So don't worry about positives and negatives. I've got 28 coming from this times this, and 2 coming from this times this. Can 28 and 2 be combined to be -26? Well, yes, as long as it's this. As long as it's -28x and positive 2x, it will combine to be -26x. So that's my correct factorization, right? I have -4 times +7, -28, +2 times +x, +2x, -28x, +2x, -26x. Now finally, back to one that's maybe a little more challenging, 4x squared plus 8x minus 5. Again, it's tricky because that 4x squared could be 4x times x, or it could be 2x times 2x. I think I'm going to go with a 2x and a 2x. All right, that 5 is 5 times 1, but it's -5. So which one is it? Well, let me put a 5 here and a 1 here. Now, what's kind of nice about it is that because I've got a 2x and a 2x, it doesn't really particularly matter whether the 1's there or the 1's there. It doesn't, because they're both 2x, right? So here I'd have 5 times 2x, right, which would be 10x, and then 1 times 2x, which would be 2x. Can I somehow manipulate these to get 8x, a positive 8x? Sure, as long as that is a -2x. And that will come if I've got this factorization. Right, 2x minus 1 times 2x plus 5. All right, let's wrap this up. Factoring challenging trinomials is undoubtedly the hardest type of factoring that you learn at this level. Thankfully, it's not emphasized a lot on standardized exams, if at all, but sometimes it is, okay? And it's challenging because it really does require you to take an intelligent guess, a guess where you know the first and the last terms are correct. The only question in your head should be whether or not the O and the I, when you multiply them all out and combine like terms, whether the O and the I will combine to give you the linear term, the x to the first term of that trinomial. And it takes patience, right? It takes patience, and it takes just sticking at it, right? Just sticking at it. But as long as you do, you will always be able to find the right answer at the end. All right, I just want to thank you for joining me for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.